Hello and welcome to your algebra recording for the week 13. We are in week 13 and we are continuing to explore and analyze functions in Unit 8. So we started Unit 8 with looking at square root functions. So before we jump into something new today, I would like for us to start with a warm-up problem and get us thinking about what we looked at last week. And we're actually going to find a lot of similarities when we talk about transformations throughout Unit 8. So I thought we would start with a warm-up that explores just that, transformations, and looking at square root functions, which we explored last week. So what I'd like you to do right now is make sure you've got your math notebook, and I want you to complete this warm-up in your math notebook. Remember, you do need to submit your notes, your weekly recording notes in the notes assignment at the end of the week. So make sure you're taking notes as you watch this recording. They will be very helpful this week. So let's dive into this warm-up. It says, describe the transformation from the parent function of f of x equals square root of x. So we're looking at a parent square root function. And we then are going to compare it to the function of g of x equals square root of x plus 5. And all of that is underneath the square root sign. So what type of transformation occurs when we add underneath the square root sign x plus 5? So go ahead and take a moment to answer this question. If you need more time, go ahead and click pause. Otherwise, I'm going to go over the answer in a moment, but I do want you to try this on your own first. So if you need more time, go ahead and click pause. All right, so what's a key thing to pay attention to is that we have the plus 5 underneath the square root sign. So since it's underneath the square root sign, we know that there is a horizontal shift. But in what direction are we going? Are we going left or are we going right? So what I'm going to do is remind you of the general equation that we use to help us decide what type of transformation occurs. Is it up, down, left, or right? So what we learned last week is that if we have the equation square root of x minus h as our general equation plus k, I'm going to go ahead and move all that up into some blank space so I can write under it here. There we go. So notice it's x minus h. There's that negative sign, that subtraction sign built into the general equation for the square root function. And what that tells us is that if the h value, so notice I didn't highlight the negative sign, just the h value. It's built in x minus h. So if the h value is greater than 0, then we're going to have a horizontal shift to the right. If the h value is less than 0, we're going to have a shift to the left. Oops. Whoa, I'm trying to move this over because I'm going to get to the k values next here in a second. So since we've added an h value, we know that there's a horizontal shift. So in order to rewrite this equation to get it to look more like our general equation up here where we have it as x minus h, we want our equation down here to match that. We want to get it so that it's in the form of x minus. And remember, we can rewrite a plus sign with a double negative, right? We can rewrite that as a double negative. So here, our h value is really, when we rewrite it with that negative value, our h value is -5. So since our h value is less than 0, that means we're going to move to the left. So there's actually a horizontal shift 5 units to the left. To the left. And that all goes back to looking at the general equation and that it's x minus h. Another thing you can think of really is looking at the original one. If it's x plus something, it's going to be to the left. If it's x minus a number, it's going to be to the right. So that's another way you can think of it. Our k value is pretty straightforward. Our k value, if k is greater than 0, we're going to go up. And if k value is less than 0, a negative number, we're moving down. So that one's a little bit more straightforward. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So this week, we're going to continue analyzing and learning about different types of functions and their graph characteristics. We're going to look at cube root functions. Last week we looked at square root, and then we're going to look at cubic functions. So let's dive right in. Reminders, check your grades often, and then the big reminder of the week is if you submit late work or redos, you have to send me a message. Remember, that is a course policy. If you're not sending me a message and you're turning in late work or redos, I'm not going to know to grade it, so you might not get your work graded. And then be patient with me if you're submitting late work or redos. I promise I will get to it, but it just takes me a little bit longer to grade later redos because my priority is to get the current work graded first and honor your time for turning in stuff on time. All right, so let's do a little bit of review. What is a cube, or how do we cube a number? So a cube is just a number multiplied by itself 3 times. So for example, what is 3 cubed? It looks like that, 3 to the 3rd. And what that means is we're going to take 3 and multiply it times itself 3 times. And I know 3 times 3 is 9, and then 9 times another 3 is 27. So 3 cubed is 27. Another example, let's do another example. How about we say 2 cubed? Well, that's going to be equal to 2 times itself 3 times. So what 2 cubed is not, it is not 2 times 3. That is not what 2 cubed is. We take the number, the base number, and multiply it times itself 3 times. So 2 times 2 is 4, times another 2 is 8. So that's what it means to cube something. We take the number and multiply it times itself 3 times. A cube root is going backwards. It is trying to figure out what a number. Well, let me backpedal a second here. So first of all, what does the cubed root symbol look like? It's right here. So it looks similar to a square root sign, except that we put a little 3 up here, right there, yeah, to show that it's the cubed root. And what we're trying to do is find what number times itself 3 times will give us the radicand. Remember, that's that number underneath that cubed root sign. So here, if we're trying to find the cubed root of 125, what number times itself 3 times will give us 125? If you said 5, you are correct. 5 times 5 is 25, times another 25 is 125. So the cubed root of 125 is just 5. What about the cubed root of 64? So ask yourself, what times itself 3 times gives you 64? Well, I know 2 times 2 times 2 is 8, so it's not 2. How about 4 times 4 is 16, times another 4 is 64. So the cubed root of 64 is 4. So that is a quick review of cubed roots. So we learned last week that we cannot take a square root of a negative number, right? So we cannot take the square root of -9. We can't do that and get a real number answer. We can't do it. It's not possible. But is it possible to take the cube root of a negative number? Let's think about that. So is there a number that we multiply it times itself 3 times that will give us a negative 125? Well, let's try -5. So it's got to be negative all the way around because it's got to be -5 times itself 3 times in order to be a cube root. So -5 times -5, that gives me a positive 25. And then if I take that positive 25 and multiply it times that last -5, what do I get? I get negative 125. So guess what? We can in fact take the cube root of a negative number. We can. So what's the cube root of -8? Well, what times itself 3 times would give us -8? Well, we know it's got to be a negative number, and it's going to be -2. So the cube root of -8 is -2. And this one up here, remember, was -5. So we can take negative cube roots. We cannot find a negative square root and get a real number answer. All right, so let's look at the graph of a parent cube root function. So we've learned about parent graphs. So the graph of the parent function of a cube root is just going to be f of x equals cube root. So let's find the cube root of a couple x values and find the corresponding y values. So we're going to plug in to our parent value or parent function of the cube root of x. So if we plug in -8 for x, what is the cube root of -8? And remember, we just figured that out. It's -2. What is the cube root of -1? Well, -1 times -1 times -1 gives us -1. What about 0? That's an easy one. It's 0. 1, it's going to be 1, and +8 would be 2. So let's plot these points, starting with -8, -2. There's that point. -1, -1. Then we've got 0, 0. We've got 1, 1. And then we've got 8, 2. So the graph of a parent function, remember, these aren't the only points. We could pick any x value and get a corresponding y value. But the general shape, if we connect our points, is going to look like that. Kind of like an S shape that we get for that graph. And in this case, let's talk about our domain and our range. So we can have negative numbers. We can find the square root, or I'm sorry, the cube root of negative numbers. So the domain is going to be, x can be all real numbers, both negative and positive. And the range, remember that's our y values, is going to be all real numbers as well. So the domain and range for cube root function is going to be all real numbers. All real numbers. And just like we could transform or translate, move up, down, right, left, our square root function, we can do the same thing for cubed root functions. So we can take this graph, we can move it up, we can move it down, we can move it right, we can move it left. So we're going to look at transformations here next. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. But I do want you to get that general shape of the parent cube root function and be able to recognize that shape. All right. So transformations of cube root functions is very, very, very similar to transformations of square root functions. So this should look familiar to you from the warm-up over here. So this is the general equation. Remember, now it's of a cubed root function where it's x minus h plus k. So remember, if h is greater, just h, right here, just the h value, if just the h value is greater than 0, we're going to the right. So let's look at an example. If it's less than 0, we're going to the left. So let's look at two examples here. If you've got underneath your square root sign and plus or minus, we're moving left or right. So look at this first example. G of x equals the square root x minus 2. So the h value is just 2. It's a positive 2. So that tells us we're going to go to the right 2 units. The second one, x plus 4, which we can rewrite as a double negative, which would mean the h value is less than 2, would mean that we're going to the, whoops, that should be the left 4 unit. So write those two examples down so you have something to refer back to. Oops, and I forgot my little cube root there. There should be a little 3 by the square root sign to show that we're working with cube roots now. So now let's look at some vertical translation examples. And our vertical translations make more sense. They're more straightforward. So if we have the cubed root of x and then outside of the cubed root sign we have a plus 2, that just means we're going up 2 units. We're going to translate this parent function and move every point up 2 units. So every point would move up 2 units, and we would get a nice vertical transformation of up 2 units. Now the next one, if I have minus 3, that's not underneath my cubed root sign of cubed root of x, that means we're just going down 3 units. So I would take each point and move it down 3 units. That would be a vertical translation. And you're going to find these transformations have a lot of similarities as we work through Unit 8. We're going to learn next about some cubic functions. So I'm going to go on to the next slide. So make sure you write these examples down so you have those in your math notebook. And then we're going to move on to cubic functions and just take a look at the parent function, and then we'll stop there. All right, so the cube, that should be cubic function. We are now going to graph the cubic function, the parent graph of the cubic function. So remember, the cubic function is just x to the third. That's a cubic function. So if we plug in -2 for x, -2 cubed gives me -8. If I plug in -1, -1 times -1 times -1 gives me -1. If I plug in 0, 0 cubed is 0. If I plug in 1, 1 cubed is 1, 2 cubed is 8. So let's go ahead and plot these points. 0, 0, -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. And when I graph those points, I get this shape. And this is what cubic functions look like. So a little bit different than cubed root functions, right? So the shape of our cube root function looked more like this. Now, if we kind of turn that shape of the cubed root function vertical, we get a cubic function graph. And guess what? The domain, so the domain and the range are going to be all real numbers, just like the domain and range of cube root functions. So this, again, is what a cubic function looks like. And make sure you jot this shape down in your math notebook. And I want you guys to start being familiar of the different shapes of the parent functions that we've learned so far. So I'm going to go on to the next slide. So if you need more time, go ahead and click pause. This week you're going to learn about the transformations of cubic functions on your own. You're going to find they're very similar, to that of the square root and cube root functions. Now though, if you have x minus h, and it's in the parentheses with your cubed root, this will be your horizontal movement. This number here, if it's in parentheses, attached to the cube, it's going to show horizontal movement. Same thing is true. If h is greater than 0, we're going to the right. Remember, it's always x minus though. And then if h is less than 0, you're going to the left. K, if it's positive, we're going up. If k is negative, we're going down. And you'll learn more in depth with that in those Schoology lessons this week. But let's review the parent functions that we've learned so far. So we started with just the square root function. And we know that that looks like this. It's got a starting and ending point. Then we learned about the cubed root function. And we know that kind of has this S, horizontal S shape. And then lastly, we learned the cubic function, which has more of a shape of that. So I want you to make sure that you are getting familiar with the shapes, and if you see a graph that you're able to look at the shape of the graph and say, hey, that's a square root function, or hey, that's a cube root function, or hey, that's a cubic function. So jot these down in your math notebook. And then I'm going to go on and give you your key phrase assignment. So if you need more time to jot these down, go ahead and click pause. All right, so we are at key phrase time. So we chatted about the translations in cube root functions. So what if we start with the parent function here, the cube root of the cube root of x, that's our parent function. And if I were to then give you the new function, g of x, which is the cube root of x plus 4, what type of movement do we have from here to here, from our f of x function to our g of x function? Describe for me the translation. Describe for me the movement. And that's it. If you need any help with this week's assignments, let me know. Remember, I'm here to help, and have a great rest of your week.